Processing. This is Balayesu, Assistant Professor of Department of CSE, is going to teach the unit number 5. Till now, we have been processing in unit number 1 and image enhancement techniques and image segmentation and so on. So in this class, we are going to learn one of the main applications of digital image processing, that is image compression. Now onwards, we are going to discuss about unit number 5. So unit number 5 mainly discusses about image compression. So what are the topics we are going to study under image compression? So first one is we are going to learn the fundamentals of image compression. So what is image compression? And next we are going to learn what is the need of data compression. And then we are going to study different types of data redundancy reducing techniques, Huffman coding, run length encoding, shift codes, arithmetic coding, and well-known standards, JPEG standard and MPEG. So these are the topics we are going to learn in this class. So coming to first one, what is an image compression? Before learning the image compression techniques, what are the objectives of unit number 5? After completion of unit number 5, the student should be able to measure the amount of information that is in the image. So that is the first objective. Student should be able to measure the amount of information in a digital image. And then student will be able to understand what are the main sources of data redundancy in digital images. And then student will be able to know the difference between the different compression techniques. There are two types of compression techniques. One is lossy compression technique and second one is lossless compression technique. And then student is able to learn what are the various standards we have, like JPEG and MPEG and so on. So these are the objectives of unit number 5. Now we are going to start with image compression. What is meant by an image compression? So image compression is the art and science of reducing the amount of data required to represent a digital image. So here I am telling that art and science of reducing the amount of data required to represent an image. How to represent an image? That is what the question here. So we know that an image can be represented as f of x comma y. And this f of x comma y can be represented in several ways. But the most famous representation or popular representation is 2D array of intensity values. 2D array of intensity values. Let us take this one. So 0, 0, let us say A00, A01 and so on, AM minus 1 and so on, AN minus 1. So if I want to represent an M by N image, so this is the best way to represent a digital image. Now if I represent the image in 2D array, so we require M into N into K amount of data is required to represent this image. If I represent the image with M into N into K, what is the K? K is number of intensity values. For example, if I have 256 intensity values, those 256 intensity values can be represented with 0 to 255. And this 256 can be represented with the 2 power 8. So this 8 indicates the K value. So therefore, for example, if I have 256 rows and 256 columns and I have 8-bit image, therefore the K value will become 8. Therefore, the amount of information in the given image is 256 into 256 into 8. So this is the information available in an image. Now our task is we have to reduce the amount of data required to represent that image. Actually that requires 256 into 256 into 8 bytes of data. Now we are going to reduce that amount of information, that amount of data. So here what are the applications of image compression? So the applications of image compression includes internet, multimedia, business, satellite imaging, medical imaging. In all these areas we are using image compression. That is, for example, if you take the WhatsApp, so in the WhatsApp we use it to send the images and videos. Actually the image size is 1 GB of data or video is 1 GB, but if we transmit the 1 GB, the internet we require more amount of data. But If I compress the data and if I transmit, then which consumes a less amount of data available with our network. So therefore, the internet and business and multimedia and satellite imaging. Now coming to image compression. I would like to recall the definition once again. So the image compression refers to the process of reducing the amount of data required to represent a given quantity of information. So here I am using two words. One is a data and the second one is information. So I would like to differentiate these two terms, data and information. So before understanding the image compression, let us start with a string. Let us take a data. So this is the information I would like to convey. The information is, this is the first representation. How are you? And same information can be represented in second way, that is, how are you? So the same information is representing in two different forms. One is the information one, first representation, and this is the second representation. Out of these two representations, which one is takes less amount of data? So here this requires less amount of data to represent the particular information. So therefore, information is the user and the data is the way in which how we are representing that information. So we may use the first form of data or we may use second form. But our task is we have to reduce the amount of data required to represent the given information. Therefore, in image compression point of view, data and information both are not same, they are different. Information is the original content, data is the term that is used to represent the particular information. We may represent the same information with the different types of data. Whenever we are using different types of data to represent the same information, we will have some problem. What is the problem? That is called redundancy problem. That is called a redundancy. So whenever I would like to perform the data compression or image compression, then I have to talk about these redundancies. So what is the redundancy? And then what are the different types of redundancies we have and how we are going to eliminate the redundancies in images. Those are the things we are going to discuss now. That is what I have given here. Various amount of data can be used to represent the same information. So whenever we are using the types of various amounts of data, then there is a probability called redundancy. So how to measure the redundancy value? Redundancy can be measured by using the formula R is equal to 1 minus 1 by C. So what is 1 minus 1 by C? Let us come here. Redundancy can be measured as R is equal to 1 minus 1 by C. So what is C? C is called as a compression ratio. C is called as a compression ratio. How to find out the compression ratio? We have the formula C is equal to B by B dash. What is the B? B is the amount of data represented,